Welcome to the world of sapphires. Valuable, unmatched beauty, rarity and purity are the ultimate qualities of this precious gemstone. Virtually unscratchable, sapphires are the only natural material on Earth as hard as diamonds. In nature, sapphires are formed from high purity alumina deep in the Earth's crust. Like any naturally occurring gemstone, heat, energy and pressure over millions of years stimulates the growth of these natural sapphire crystals. Today, mankind has the technology to recreate the formation of sapphires using high purity alumina under intense pressure and heat. The formation takes place in high-tech furnaces where large single sapphire crystals are grown from high-quality alumina. From these crystals, sapphire wafers and sapphire glass are extracted using diamond cutting technology. These synthetic sapphires
Cue video. I'm not sure what's happened there. We can't read. Okay, run out of memory. All right. Thanks, ladies and gentlemen. Drinks will come on a little quicker than expected, I think. Look, it's a pleasure to be here and introduce Altec Chemicals to you. We're a Perth-based company and we're aiming to become a world leader in the manufacture of high purity alumina. Now, as the video was about to say, in nature, high purity alumina forms rubies and sapphires, similar to the way carbon forms diamonds, but it's the impurities, typically iron and chromium, that give sapphire and ruby their colour. If you want to make artificial or synthetic sapphire, you want a high purity material, and this is where high purity alumina comes into play. You do not want any impurities. Now, for those of you doing the quiz, I think there is a quiz in your blue bag. Question number 1 talks about the hardness of sapphire compared to diamond. Now, diamond is a perfect 10 on the Mohs scale. Sapphire is a 9, so it's not as hard as diamond, but almost as hard. So high purity alumina, what is it? As the name suggests, it's high quality aluminium oxide, 99.99% purity or 4N. Quite different from smelter grade alumina, which has about 0.3% sodium in it and runs at about 99.5%. So you cannot use smelter grade alumina nor aluminium metal for the production and manufacture of synthetic sapphire. You need a much cleaner material. So like all industrial materials, as quality and purity increases, so does price. So in the case of high purity alumina, the market price is between $27,000 and $40,000 a tonne. At the currently the price is more around the $40,000 a tonne mark. There's two main segments of demand for high purity alumina. One is the synthetic sapphire manufacturing business, and the other is in the lithium-ion battery industry. The first segment there is well established, and the main use for synthetic sapphire is in the manufacture of LED lights. The second segment there is evolving, and I'll talk a little bit more about that later on. So if we look firstly at the synthetic sapphire business, so high purity alumina, typically in beads, is fed into kilns. And under intense heat and pressure, around 2000 degrees centigrade, the high purity alumina is melted to form a large single crystal synthetic sapphire bull. In this case, it's a 350 kilo bull. From the bull, using diamond cutting tools, they cut cylindrical cores horizontally through the bull. Then the cores are shaved to produce substrates for LEDs or semiconductors, or alternatively, slightly thicker wafers are cut and they're shaped into glass shapes or scratch-proof glass. Commonly, you'll see that on your watch faces, camera lenses, but also increasingly on smartphones. Now, LEDs are rapidly replacing traditional incandescent bulbs, fluorescent bulbs, halogen lights throughout the world, and the demand for LEDs is growing at a constant sort of 15 to 16% per year. And you can see the cross-section of the LED lights the vast majority of LED lights have a synthetic sapphire substrate, which is produced from high purity alumina. Now, turning now to glass applications, the most commonly understood application is in your iPhone. The camera lens of your iPhone will not scratch unless you use a diamond. The same with the fingerprint recognition. And more we're seeing companies such as HTC, Vertu and others use a synthetic sapphire screen on their phones. So how hard is this material? This is just a demonstration. Hopefully this video plays its full extent. It's got sound. Yeah. So if you own an Apple Watch, you can try that at home tonight, see if it works. So we turn now to the growing segment of demand, which is in the lithium-ion battery sector. And here, high purity alumina is used in fine particles, nanoparticles, less than a micron, and are supplied to the separator sheets that sit between the anode and the cathode in the lithium-ion battery and stop those from touching. If they were to come into contact, there'd be a short circuit in the battery and quite a spectacular fire would be evident. And I think we've all seen evidence of that with the Samsung tablets or phone fires. So this is quite a busy slide, but it tells an interesting story. So the graph on the left and the light blue line, what it's showing is the increased energy intensity in lithium-ion batteries. And this is being driven by a move towards nickel-based cathodes. And I think some of the presenters today and definitely tomorrow will be talking about the impact that's expected to have on the demand for nickel sulfides. Now, the consequence of continually packing more energy into a tighter space in a smaller battery is that the operating temperature of the battery increases. So the heat within the battery is ever increasing. Now, to the bottom of this slide, on the left-hand side, is the traditional separator sheets that they're using in the battery, and it's a tri-layered polymer sheet. This is what's used traditionally in lithium-ion batteries, and it can operate to a temperature of around 135 C. But with the increased energy density, that's not doing its job well enough, and there's propensity for those sheets to shrink, and if they shrink, as I said before, it'll allow the anode and cathode to come into contact. So what separator sheet manufacturers are doing is they're transitioning to high purity alumina coated sheets, and this will increase the battery operating temperature to around 200 C before there's any chance of the separator failing. Now this transition is a relatively new phenomenon, and the example on this slide is a publicly listed Japanese company, WScope, which specialises in separator sheet manufacturing. And because it's a public listed company, it publishes its data on sales. And what we see on the left is its Q1 2017 sales. And you can see that it was selling no separator sheets into the automotive industry. And about 11% of its revenue was derived from separator sheets sold into the consumer goods industry. Wind forward 12 months and the amount of revenue being derived from consumer goods separator sales has tripled to 33%. And all of a sudden, around 6% of revenue is generated from HPA-coated separators into the automotive industry. So this transition is happening, it's real, it's probably come on, fair to say, quicker than we expected, but WScope is representative of half a dozen or more separator sheet manufacturers in the industry. So all bodes well for this next slide, which is a forecast on HPA separator demand. Look, the market for HPA separators is minuscule at the moment, less than 1,500 tonnes a year used in that. But if you buy into the electric vehicle, the transition to battery and electric powered vehicles, we'll see that demand for HPA, close to 10-fold increase by 2025-26. Likewise, for general demand forecast for HPA, which is underpinned traditionally by the growth in the LED industry, growing at around 15% a year. But then if we add on the lithium-ion battery separator sector, we see nearly 90,000 tonnes of demand by 2025, and our plant will bring on only 4,500 tonnes. So there's plenty of growth for us and any other entrants into the HPA market. HPA is currently produced. It's a product that's produced typically by large chemical or large industrial conglomerates, and some of the names you'll recognise there, Sasol, Nippon Light Metal, Sumitomo, etc. And the way they produce high purity alumina, you cannot use, as I said before, smelter grade alumina. So typically what they do is they buy aluminium metal. They have to reprocess it to remove the impurities and typically the sodium out of the metal, and then turn it into high purity alumina. It's quite an expensive process, and we all understand that the aluminium process is extremely energy intensive, starting with bauxite through to smelter grade alumina, then to aluminium metal. Now, Altech's process is a robust and well-known process, basically taking kaolin ore. Kaolin ore, our deposit is in Meckering in Western Australia. It runs about 30% alumina. So using a HCl process, we extract the alumina in one single step, and much more energy efficient and lower cost extraction process. That's just a brief slide on our deposit, very low in impurities, and we have enough material there to support our 4,500 tonne plant for over 250 years. Long before I'll be gone. Yes, look, the Meckering deposit, it's ready to go. It is on freehold farmland. We've purchased that land, so we own the freehold, we own the mining lease. It's fully permitted, and it's a very simple operation. In 2 months, we can mine 3 years of supply, which is around 120,000 tonne for the plant, and then it becomes a simple container loading and shipping operation from Western Australia up to Johor in Malaysia, which is where we'll build our plant. So Johor is just across the road from Singapore. You can see where it is from Meckering or from Western Australia. There's a weekly ship that runs between the Port of Fremantle and Johor. So we'll simply load our containers and backload them, about 30 a week, up to Malaysia. The operating costs in Malaysia are quite attractive, about 60% of what we could operate this plant in Australia. And because we'll be classified by the Malaysians as a high-tech manufacturer, we'll enjoy a 5-year zero corporate tax window, and then the corporate tax in Malaysia is only 23%, where it's stuck here in Australia still at 30%. So it's a very attractive destination for us to do business. That's a schematic of our plant, which is all designed by German engineers, and it's ready to start construction now, pending the closure of finance. So our process, as I mentioned before, it's well established. It was used by the Americans in the 1980s, the end of the Cold War, to prove that they could extract alumina from their huge kaolin deposits in Georgia. It worked quite well. It produced very high-grade alumina, but at that stage there was no real demand for high-purity alumina. Synthetic sapphire wasn't highly demanded. LEDs hadn't really taken hold in the marketplace and been commercialised. And it's a much lower cost than the established way of producing high-purity alumina. And demand is definitely here today with the 2 segments I talked about. There's where we'll sit on the operating cost curve, about a half to a third of traditional producers that buy aluminium metal. In terms of constructing the plant, we've appointed German EPC contractors. We have a fixed price lump sum turnkey contract, so they will build the plant for us and hand the keys over when it's running. They'll guarantee the throughput, the quality and the production of the plant in its whole. They've also invested in Altech. They invested $5 million late last year, and they'll invest another $10 to $11 million in the coming few months when we close financing. So they hold about 8% of our share register now. Offtake, all of our product is being sold to Mitsubishi, the Japanese trading house, for 10 years, and they will on-sell that to their customers. A strategic relationship for them. They need to supply their customers for material into the lithium-ion battery sector. Project finance, the senior debt is done through the German government-owned bank KfW IPEX, $190 million of debt. 170 is export credit finance, which is low interest, long tenure, and that is available to us because of the German content in the plant, but also the German EPC contractor. These are the project economics just quickly before we close. So NPV of about $500 million, and this is based on a capex of 280 million and 298 million, sorry, and the current market or the historic price of $27. The current market price for high purity alumina is more like $40,000 a tonne. So if you put the current market price in, no surprise, the NPV of the project doubles and the internal rate of return 33% and a very quick payback of 2.2 years. Just to finalise, so here's the project status. I mean, we announced our final investment decision study late last year. We have the sales contract with Mitsubishi. We own the Malaysian HPA plant site. It's a 4-hectare site in an established industrial park in Johor, just across from Singapore. We own the Meckering lease and the freehold. We've got our project finance senior debt done. EPC contractors appointed. We're just working on the balance of funds to get the project started, and we hope to start construction towards the second half of this year. The genie is out of the bottle now. For high purity alumina, this is just an extract from the Mining Journal a couple of weeks back. CRU is a London-based commodities analysis and research firm, and in this seminar, Mining Journal reported how CRU has reported that car makers, and CRU, I understand, has a very rich database on the EV industry, and car makers are now turning their sights on securing supply for high purity alumina for, as I said, the separator industry. Just to summarise, that's a chart of our market cap over the last few years. So we started off at around $5 million market cap. We're now sitting at 70 versus a project NPV of around $500 million. So there's still quite a gap between the market cap and the project value, but there's been a tenfold increase. We've got about 426 million shares on issue, and we had 7 million at cash at the end of the March quarter. So, wrong way. So we really believe we're in the right place, the right time. We have certainly a quality feedstock at Meckering in WA, and we have the right technology, and we're ready to capture the pending demand inflection for high purity alumina. So thank you very much, ladies and gentlemen.